shock tube. Very simple construction. Okay, it is just like your holy pitchkari also, if you want, we can say. Yeah. Now it is, it comes, my diagram is running somewhere. Okay, I'll first draw and then I'll enlarge. Okay, it is no. Okay, it consists of a cylindrical tube. Reddy shock tube consists of a cylindrical tube of length 1 meter. Okay, the length of the tube is, I'll draw it right here, 1 meter. Okay, and its diameter is 30 millimeter. 30 millimeter. That means how many centimeters? The diameter of the cylindrical tube, which is mostly made up of stainless steel. It is made up of stainless steel tube of length 1 meter, diameter 30 millimeter. That means how many centimeters?
3.
3 centimeters. Who is that?
Pawan.
Pawan. Which Pawan? There are 2 Pawans. One is Pawan Kumar MV. Another is Pawan P CA014. I think 014, right?
Yes.
Pawan?
Pawan P.
Pawan P CA014. Okay. Okay. Right. So diameter is 3 centimeter. Okay. Yeah. Now this cylinder is divided equally into 2 parts. Okay. By we use our diaphragm here. Our diaphragm is used. You know, a diaphragm. Okay. A diaphragm. This is made up of either paper or a very thin strip of metal. Okay. It is made up of very thin strip of metal, and this thickness will be hardly 0.1 millimeter. Can you guess? Thickness of paper is almost that much only. So the diaphragm, which is made up of paper or a thin sheet of paper, metal, is of thickness 0.1 millimeter. This diaphragm separates this tube into 2 parts. Okay, this part, this portion, and there is a piston. What you see here is a piston. Okay, and so this we are going to use our hand to push this piston inside. That is why I said this Reddy shock tube is just like your holy pitchkari. Okay, right. Now this is what is going to be special about this is Reddy shock tube is we are not going to use any electricity, okay, or anything. We are just using our human hand. We are going to give, we are going to use our hand only to push the piston inside, and what is going to happen? Shock waves are going to be produced. So this is one of the features of Reddy shock tube. It is a hand operated shock tube. It is only a hand operated shock tube. Okay. Yeah. So this is the starting. Starting is called upstream end. This is called upstream end. Yeah. So can you guess what is the other side called? What is this portion called? That this is upstream end. This is downstream. Okay, this is downstream end. Right? And I mean, in some of the shock waves, no, this portion will be open, and some case it is closed. But in Reddy shock tube, this downstream end is closed. Okay, right. Now here is a gas. Okay, here is this gas is there. This is called driver gas. Okay, can we complete here? What is that called? The other side. What is the other side called? I expected someone to say something. Driver gas. Okay, no answer. So this is driven gas. What is this gas called? Driven gas. Okay, so this is going to drive the gas here. This is going to driven gas. What is the reason? We will see. Okay, now mostly this gas is helium. This gas driver gas is used is helium, and this driven gas used is argon. Argon is a gas. Okay, yeah. Now here this pressure, this gas now will be at high pressure. Pressure of this gas will be more. Pressure of this gas will be more, and here the driven gas will be at less pressure, and we are using a port to send the this is also called test gas. We are going to why this is called test gas, because here only shock waves are going to be produced. Shock waves are going to be produced at this place, and now we have a sensor. Okay, we have a pressure sensor. This pressure sensor is going to, this is called digital pressure sensor. Digital pressure sensor, and this is going to sense the first shock waves. So this digital pressure sensor is kept very close to the diaphragm. Okay, and then what we have two sensors. This is S1 and this is S2. They are separated by a distance of 70 millimeters. That is a standard value they're using, the distance between them. So this X equal to 70 millimeter. This is the millimeters. This is the distance between the two sensors. Okay. Now, can you guess what is the work of the sensor? From the word itself, sensor.
Sense shock waves, ma'am.
Yeah, very good. It is going to sense the shock waves. Okay, and then we have here CRO, cathode ray oscilloscope is there. This is connected to the CRO. That's all. Okay, right. So tell me. So just a recap. Now, before I tell, this is the construction of the Reddy shock tube. So before I complete the construction, you will tell. You can guess what is the working. Shock waves are going to be produced in the driven section. Okay, so let us just, so can you guess what is going to happen? I have a piston here, I have gas here, I have a diaphragm here. Okay, normally, the diaphragm is fixed to a very small support. There may be two diaphragms or one diaphragm. Okay, a very small support, like a paper is fixed to the in the sonometer. How we fix it will be fixed like that. Okay, now can you guess what will happen when I push the piston? I push the piston very hard. The pressure of this gas is very much more. What will happen when it passes here? Will the diaphragm reverse?
Diaphragm rupture.
The diaphragm will just come out. Okay, from this small fixed end, that is called the diaphragm ruptures. Okay, the diaphragm will rupture, and what will happen immediately? All the gas will rush here. That's why the density of this gas is more. What will happen when this rushes very fast and see the medium is less? That is not it's not like a classroom. It is only 1 meter cylindrical rod. What will happen when it rushes very fast here? It will, I think you can complete. What will happen? It will compress the driven gas. Okay, it will compress the driven gas, and can you guess what will happen? Shock waves are produced. When this gas, very simply it can be produced. So when the driver gas is pushed and it this diaphragm ruptures and it presses the driven gas, what is produced? Shock waves are produced. Okay, now this is called primary shock waves. Okay, so this shock waves, the waves which are produced by compressing, is called primary shock waves, and this is noted by the first sensor S1. Okay, first sensor S1, and then what will happen? The shock waves goes, and because this is a closed end, it again comes back. It is reflected back. This is called secondary shock waves. Okay, this is called primary shock waves. This is called secondary shock waves. Secondary shock waves are noted by S2. The second sensor S1, S2. Yeah, someone is trying to unmute. Yeah, what's the doubt? What is the doubt? Someone is trying to unmute the mic. I don't think you'll ask doubt. Okay. See, the diagram looks quite dirty with this board. Right. Now tell me. So what are the things? What I said? So this is the primary shock wave. It goes. So this primary shock wave which is produced is noted by the sensor S1, and immediately it produces a signal in the CRO. Okay, it produces a signal in the CRO. And tell me, what is the work of this digital pressure sensor? What is the work of this digital pressure sensor? It senses the pressure of the diaphragm. While the diaphragm ruptured, that pressure is noted by this digital pressure sensor. Right, now it comes back, it gets reflected, and that shock waves is called what shock waves? Secondary shock waves. It is sensed by S2, and how it is sensed? It is sent to CRO, and CRO produces one more signal. Okay, it produces one more signal. Now from this we can find the velocity of the shock waves. How we'll find the velocity of shock waves? It is defined, velocity is distance defined as what? In general, what is the definition for any velocity? Yeah.
Ma'am, can you once again say what happens after the primary shock wave? And,
I am going to repeat. I'm going to repeat the construction and the working also. Before that, can you tell me what is the definition? US means velocity of shock waves. What is the definition for velocity? Definition of velocity is
Displacement by time, ma'am.
Distance by time. Only 2-3 girls answer and one yeah 2-3 boys also answer. What about others? Yeah, US means a velocity of shock waves is equal to distance by time. Here the distance is already given. Okay, how much it is? Distance between the two sensors is 70 millimeter by time. How to find time? The CRO will give us time. What is the full form for CRO? CRO full form? PU you had CROs, no? What is full form for CRO?
Cathode ray oscilloscope.
Cathode ray oscilloscope. Good student. Here's the number.
ME008.
Pramukh Yoga Tejasvi. Okay, right. Noted. Right. That is what. So where we stopped? What I said? Yeah, CRO stands for cathode ray oscilloscope. Okay, students. Yeah. Now she wanted recap. So let us say, what is the starting we said, Reddy shock tube is used to produce shock waves. Okay, by using human mechanical energy is used to produce that. Okay, it consists of a aluminum cylindrical tube, aluminum cylindrical tube, like you did for this tube is just like you did resonance column, no? You remember one resonance experiment you'll do with the water column. It will be like that, huh? Right, and then the length is 1 meter, the length is 1 meter, the diameter is 30 millimeter, that is 3 centimeter. It is because 1 meter it is no equally divided into 50 centimeter and 50 centimeter. We call this as the first portion is upstream end, the other is called downstream end. There is a piston, the piston is fitted to the cylindrical rod. Okay, and then at the center is a diaphragm which is made up of paper or the metal of thickness only 0.1 millimeter. Okay, you should not get confused and write meter and don't say it is a small mistake. It is millimeter. Okay, and just close to the diaphragm is a digital pressure gauge which is going to check it is going to measure the rupture pressure when the diaphragm breaks, right? That is what we saw. There are two sensors, S1 and S2, near the downstream end. Okay, this sensor's work is to sense the pressure. Right, now what I said, when the piston is pushed, the driver gas is of a more pressure density, the pressure is more, so it comes here, it ruptures this diaphragm, goes here, okay, presses this driven gas also, which is the test gas, and shock waves are produced. These shock waves which are coming here, going that side after they have compressed the gas is called primary shock waves. It is noted by S1, right, by producing a signal in the CRO. And then because there's closed end, it comes back again and again it compresses the gas, producing secondary shock waves. Okay, so the shock waves which is produced due to the wave coming this side is called primary shock waves, and when it comes back it is called secondary shock waves, which is noted by S2. Yes. What is the doubt? I think Aditi only asked the doubt. Is it clear now?
Yes, ma'am.
Okay, a very simple construction. You can just think and do it also. And so these sensors are connected to CRO. CRO gives the time taken by the shock waves to travel from S1 to S2, and from that we can calculate the velocity of shock waves. We can also calculate the Mach number of the shock waves, because Mach number is given by US by A. A is the velocity of sound. That is, we are taking here as 340, and whatever be the velocity of shock waves. Okay, now here one thing to remember, now it produces a very high temperature. Okay, suddenly what will happen, within these shock waves are going to should not last for a long time, because they are going to there will be a very high increase in temperature, density and pressure in a very short time. Okay, these microwaves are going to last only for milliseconds. Okay, before that, if it is going to last, it is going to create problem. Only for milliseconds the shock waves are going to exist, because before that what will happen, to be safe, there will be one expansion wave coming from the driver section. What is that wave? I'm saying one wave called expansion wave. Expansion wave created inside only will come and neutralize the shock waves. The expansion wave from the upstream end comes and neutralizes the shock waves before, and it will not allow it to last more than milliseconds. Now tell me, Who will answer? From where these waves came? One expansion wave will come from the upstream end and neutralize the shock waves and not allow it to last for more than milliseconds. It's quite a risky instrument. Some 4 or 5 years back, no, the one scientist in IAC who was working in shock waves, he died while performing the experiment. It blasted. That tube blasted. Yeah. Now tell me, from where this expansion waves coming? From where is this expansion wave coming? Fast. Any idea? No one produced from outside. No one produced from outside. It was produced inside only. Very fast. Yeah.
Helium gas, ma'am, when it is
No,
compressed.
It is only gas. It is only gas.
It will get expand, ma'am, when it get compressed.
No, name is expansion. How it will get expand? No. Next. Time is 1:58. Tell me. Anyone? Very basic law is there. Very basic law. Because of that, expansion gas is produced. Fast. Expansion waves are produced. Anyone is able to guess?
Ma'am, because
Yes.
it rises temperature and pressure over driven gas, ma'am.
That is driven gas. Before that itself, okay.
When the compression is applied on driver gas, it increases the pressure over driven gas, ma'am. So your expansion.
This expansion gas is produced only after the shock waves are produced. Okay. When the shock waves are produced, after that only this expansion gas comes very fast from the upstream end and neutralizes it. From where this expansion wave came? Very basic, based on Newton's third law. Based on Newton's third law, when the diaphragm ruptured, okay, and the gas pushed this side, what will happen in this side also? Because of this disturbance, when the gas is pushing the diaphragm ruptured, there is another gas immediately produced in the opposite direction. Okay, it goes here and then it comes here as what gas? Expansion waves. Understood? During the when the diaphragm ruptures, when the gas is moving forward, immediately there should be some gas will move backward, isn't it? Because of this Newton's third law, and it will come here, and this expansion wave will come and neutralize the driven gas. Okay, students, right? So this is the working of Reddy shock tube. Time is 2 o'clock. You will go to assignment and take the quiz up to 2:10. I know you are very smart. Okay. Coolly you can take, don't be very tense. It's only for you people trial. So I'm online. Time is 2 o'clock. Go to the quiz, open it, answer the 10 questions. It will log out at 2:10. 2:10 the quiz will close. Okay, I'm waiting. Any doubt you ask me. I'm online. If opened, say yes. If quiz is opened, say yes.
Yes, ma'am, open.
Yeah, carry on. Ten minutes is quite a long time for very simple questions I've given.
And the one with name and shockwave, that is only, ma'am.
What is it? Yeah, only shockwaves. Yeah, only shockwaves.
Ma'am, eighth question is not seen only, ma'am. It's given
Why?
option 1, option 2.
What is the question?
Ma'am, it is not given question. It is given and option 1 and option 2.
Ma'am, that's question number 9 for me.
9 is
Question
also not there?
16.
7 for me, ma'am, that question number.
Oh, it shuffled the questions. One question, the questions were shuffled. So one question you're not able to answer?
No, ma'am.
There
Only
is no
one.
question, ma'am.
Okay,
Ma'am,
okay.
question is only not given, ma'am.
Okay, one question is like that, right?
Yes, ma'am.
Okay, do the others.
Yes, ma'am.
Do the others. Finished?
Yes, ma'am.
Good. Submit it. Tell me your marks.
Yes, ma'am.
Yeah. You
Ma'am,
got your marks?
showing
You
8, but only 1 is wrong in that, ma'am.
okay.
Ma'am, one is wrong, ma'am.
Question is wrong?
Yes, points is 8, ma'am.
Okay, okay. 8 after 9. 8 after 9, right?
Yes, ma'am.
Okay. We'll wait for this.
One question is wrong, ma'am. Even mine.
Okay. So the quiz is for 9 marks, not 10 marks. I'll call the names. You can no. I'll be getting the response. No, I'll check there. I'll find out how many I've got there. Two 7 it is. 210 it will block you.
Ma'am, done, ma'am.
Good.
You see, ma'am?
Yeah.
Ma'am,
Ma'am,
submitting, it's not submitting.
Why?
It's saying one question needs to be complete. Ma'am, okay. Just a second.
Then how
Ma'am?
you got? Yeah. Tell me.
ma'am, you have removed my name from the P-Cycle team, ma'am. I'm not finding any assignments.
Tell me what is your name?
Rohit, ma'am. CA20.
No, Rohit. CA020.
I'm not.
I'll check. I'll check you. I'll check how. Maybe before yesterday I updated. No problem, Rohit. Maybe
Yes,
it
ma'am.
was a previous time. It was we removed.
Yes, ma'am.
But then how you attended the class if you're not in channel?
Ma'am, I got link from This ma'am.
Friends, that is a problem. Teachers are becoming smart. You are becoming over smart. See, see, and see this by this time, you people have managed to copy also. Did you do that? Students are able to copy also, right? Next time, no time will be 5 minutes. I think 5 minutes is sufficient, isn't it? 10 questions, 5 minutes, so that you cannot.
ma'am.
Okay, good. Okay, good. Right. So yeah, 2:10. Let me see if it blocked you or not. Anyone is trying to submit and it is you're not able to submit because time is 2:10. Yeah. Okay. Yeah. So students come back. Tell me who got 9 after 9. USA number. You tell me.
CA10 ma'am.
CA10 is Kishan. Kishan Shinde got. Next, who got 9 after 9? That Pawan P CV CA014 got 9. Okay, so the questions are simple, right? So you can answer the questions only if you are in front of the system. Okay, right. Okay, students, now it is 2:10. So let us continue. This I showed you. Okay, yeah. So construction quite simple. So I thought I should draw a little neat. So I have drawn this again. When you are writing the test, I do this. Same thing. Okay, so there's no much to. So helium is the driver gas, argon is the driven gas. A port to make the gas enter. CRO is that is there. Okay, upstream end and downstream end. Right. So if you write the this thing, you'll get the. It is a lengthy answer. So you get maximum marks is for length is 8 marks in physics. So you get 8 marks for that. Okay. Now only thing we have to tell the characteristics of this Reddy shock tube. Characteristics of Reddy shock tube. What is special about it? First point is, it is we said no. It is a human shock waves are produced using mechanical energy. That is one of the properties. Okay, and it is based on the principle of free piston driven shock tube. That means what? We are using just piston, isn't it? We are just using the piston. So it is based on the principle of free piston driven shock tube, right? And then it can produce the shock waves which are produced can have a temperature of 900 Kelvin. You have very high temperature the shock waves can produce. That is another characteristics. And the shock waves can have Mach number more than 1.5. This is another property. Okay, so what is the first property? It is a free piston driven shock wave. It can give temperature up to 900 Kelvin, right? This temperature we will use for chemical for the study of chemical studies, kinetic studies. We can use this energy, and shock waves can be produced up to 1.5 value, and this rupture pressure depends on, it is very easily operated shock tube. This is the advantages. Okay, time is 3 minutes. I leave you. Let us do this one question. This one question we'll do. So take this. The distance between two pressure sensors in a shock wave is 150 millimeter. The time taken by a shock wave to travel the distance is 0.3 milliseconds. Note that. You write only the given data, because this numerical PPT I will share. Right. So let us write the given data. So given data. What is that? The distance between two pressure sensors in a shock wave is 150 millimeter. So what is this 150 millimeter? What is the symbol here I should use? Distance means what here? Distance, you all, I think you got tired after giving the quiz. Distance is x. Okay, x equal to 150 millimeter. I should not write anything in millimeters. So convert it to meters. How much I'll get? 150 into 150
10
into
power minus
-3 meters. Okay. Now time it takes. The time taken by a shock wave SW shock wave to travel distance is 0.3 milliseconds. 0.3 milliseconds. So tell me what is the value? 0. Milli means 0.3 into 10 power How much? Milli.
-3, ma'am.
-3 seconds. Okay. Now, what they've asked, find the Mach number. Mach number is defined as velocity of the shock waves, any velocity. Okay. If you don't want to write shock waves, no need, by velocity. Okay. A is also given. Did I write? A is 340. They have given, we were discussing about 333. They given 340. That's all. So A we know. A is known. You don't know velocity. Velocity, I said no. Velocity is equal to distance. Okay. We have a eraser here, so we'll use that. We use that. Yeah. So what we have, what I said, velocity is equal to distance by time, or I'll write x by time. So tell me this answer: 150 into 10 power minus 3 by 0.3 into 10 power minus 3. How much? How much? Five.
500.
500. Good. Here's the number. 500 meter per second. Here's the number.
6, ma'am.
CA.
Yes.
Dhruti, no? Dhruti, yes. Okay. Velocity is 500 meter per second. We found out. And now substitute and get the Mach number. So I have 500 by 340. What is the answer? 500 by 340. The answer is
1.47, ma'am.
good.
Ma'am.
Unit?
No unit, ma'am.
No, you.
No, yeah, it has no unit. That's all. 1.47, no unit. Good students, right?